Welcome back to Josh Does Math. In this problem, we're going to be taking the derivative of a function using the quotient rule. If you don't know the quotient rule, I wrote it right up there. You use the quotient rule whenever you take a derivative of a quotient. And an easy way to say it is derivative of top times bottom minus derivative of bottom times top all over bottom squared. That's just a quick way to memorize and recite the quotient rule. So here it is in case you don't know it. And that's what I'm using to take the derivative of this function right here. So let's get started. Derivative of the top. That's going to be 2 plus, using the power rule right here, power out front, one smaller on the power, 24x to the third, and I'm using the power rule again, minus 12 and x to the fifth, one smaller on the power. There we go. Derivative of top times bottom. What's our bottom? It's x to the fifth. Minus derivative of bottom, that's going to be 5x to the fourth. I just use the power rule. Times top, 2x plus 6x to the fourth minus 2x to the sixth. All over bottom squared, which is going to be 10 to the fifth squared. And using the power of a power rule, we know that that is just x to the 10th. Just multiply the powers. Now we're just going to distribute some stuff. So we have 2x to the fifth plus 24x to the eighth minus 12x to the 10th minus 10x to the fifth minus 30x to the eighth minus plus 10x to the 10th, all over x to the 10th. We can combine a couple of things right here. Our x to the fifth terms, for example, we get negative 8 x to the fifth. Our x to the eighth terms combine, and we get negative 6 x to the eighth. And our x to the 10th terms combine, minus 2 x to the 10th, all over x to the 10th. And you can factor out a factor of x to the fifth in the top and bottom and divide that out. So you're going to be left with, say, negative 2x to the fifth. I'm rearranging a little bit of stuff here too. Minus 6 x to the third minus 8 x, no, minus 8 all over x to the fifth. So if I did that right, I just rearranged some stuff that we have our leading power in front, and I just divided by x to the fifth in the numerator and denominator, since that's the highest power that we can pull out of each of these guys in the top here. And that's what we're left with. So that is the derivative of this original function up here. So as you can see, all I did was use the quotient rule to boil it down to this as our derivative. Thanks for watching.